Hello, everybody. Today we'll be discussing various topics in Python, such as operators, variables, constants, escape sequences, interaction with users, and many more. So, firstly, we should start with the most basic out of all of these, the operators. So, what you need to know is firstly, there's like three main types of operators. So, there's arithmetic, relational, and logical operators. So the arithmetic operators, as you can see, like if when you think of arithmetics, like you think of math, right? So arithmetic operators, they you take numbers and they do operations on numbers and they change the numbers. So some examples include addition, subtraction, multiplication, division, taking the square root, percentage, which denotes remainders, and squaring a number. And next we should move on to relational operators. So what they do is they compare the values between two different variables and they return Boolean results like true and false. So examples include equal to, not equal to, greater than, less than, or like greater than equal to and less than equal to. Now we move on to logical operators. These combine conditional statements and return Boolean results. So some examples are and, or, and not. So what and does is if two statements are like true together, it returns the value of true. Or is like if one of the statements is true, it returns the value of true. And not is it just inverses whatever's like inside it. So like if something's true, if you put it inside a not condition, it will return false. So here I have some code to demonstrate arithmetic operators. So we have some examples such as we define two numbers such as number one is 10, number two is 3. So like when the result is number, excuse me, when the result is number one plus number two, you just get the addition of the two numbers. Then we have the subtraction, multiplication, division, the quotient division, the remainder, and the exponentiation. So I'll just run this part of the program first. So you can see 10 plus 3 is 13, 10 minus 3 is 7, 10 times 3 is 30, and 10 divided by 3 is this large, like not that large, but like recurring decimal, like 3.33. And the floor division, you just get 3, so it just takes the main number and you don't get the decimal part of it. For the modulus, 10 percentage 3 is 1 because like when you try to divide 10 by 3, like you just get a remainder of 1 because like 3 times 3 is 9 and you have 1 left. And exponentiation, like 10 to the power of 3 is 1,000, so that's what it represents here. So now let's look at some relational operators. So we have two variables here, x and y, like these are 5 and 10 respectively. So we compare the two numbers, x and y. So we see if x is equal to y. So when there are two equal to signs, it represents that it checks if one of them is actually equal to the other one. And then the next one is the exclamation sign and equal to, it shows like is like one of them not equal to the other one. Then the third one we have here is if x is less than y, then you have x is greater than y. You have x is less than or equal to. So what this one does is like this returns true for both if it's less than and even if it's equal to the other one. And similarly for the last one we have x is greater than equal to y. So this will return true if the value of x is greater than y, and also it will return true if x is equal to y. So I'll just run this part of the program. So relational operators. So 5 is actually not equal to 10. So 5 double equals 10 is false. So for not equal to, it returns true because 5 is not equal to 10. For less than, it returns true because 5 is less than 10. For greater than, it returns false because 5 is greater than, because 5 is less than 10, sorry. Less than equal to, it returns true because 5 is less than 10. Even if we had 10 in x and 10 in y, it would still return true because they're equal. And for greater than equal to, it returns false. So now we should move on to logical operators here. So we have to define Boolean variables. So like you take a variable and you say if it's either true or false. So here we have is sunny, which is true, and is warm, which is false. So here we have an AND statement, which is like the result will return true or false if both of it will return true if is sunny and is warm if they're both true, and it will return false if, even if either one of them are false. Now the OR statement is a bit different because like it returns true even if just one of the two variables are true. So in this case, it should return true and one should return false. For not is sunny is true, so not just reverses it, so it should return false. So now we can combine many of these statements inside brackets, and we can have a complex logical expression. So like, if is sunny, like if you compare the inverse of is warm to is sunny, and if they're both the same, if they're both true, it returns true here. And now we have not is sunny, so the inverse of is sunny, and we compare it to is warm, and if they're both true, it returns true. And here in the middle we have an OR condition. So if either one of them are true, it should return true. So now let's see what the result is. So is sunny is true and is warm is false. So is sunny and is warm is false because is warm is false, and since one of them is false, like the AND statement is going to be false. For OR, it's true because one of them is true. So is sunny is true, so it makes the OR statement true. For not, it should be the inverse. So is sunny is true, so the inverse of it is false. For the complex expression, the answer is true because both of the brackets contain the true logic. So when they're both the same, I'm sorry, this is the OR statement. So one of them had, at least one of them had a true, at least one of them resulted in a true condition. So this caused the entire statement to return as true. So this is just like some of the like basic operators, like many programs you might use in the future, just like they're just made up of like combinations of these. So now I think we should move on to variables and constants. So like this whole time I've been discussing about like comparing variables, adding them, subtracting them, checking if they're true or false. Now let's just dive more into what variables and constants are. So here again I have some code. So for variables, we have like a lot of type of variables. So we have integers, so like they're like whole numbers, like you don't have any decimals, but they're still numbers. You can add them, subtract them, and like do all of the things you have shown above. And then we have floats, which are like decimal numbers, so like 3.1 for like pi or something. Then we have string variables, like hello Python, like these are just like sentences, alphabets, like some other characters such as commas, full stops, and some more. Then we have Boolean variables, which are like just true and false. Then the list is a data structure which contains variables inside of itself. So there are like many elements inside a list. So we have 1, 2, 3, just like 3 numbers inside a list here. And a list can like only contain one type of. I'm sorry. List can contain only one type of variable, and then now we have dictionary. So dictionary. So a dictionary, what the dictionary does. I'm sorry for just blacking out. So a dictionary, so like when you look at an actual English dictionary, like you have one word and then you have the meaning of it. So it's actually like that. So it connects two different it connects two different values together. So like for the name value, it connects it to Alice, and for the age, it connects to 30. And now the string in any here, it shows that the first one it has to be a string, and the value it connects to can be anything like an integer, float, or another string. So so we're now here. These are the functions for printing all the different data types. You can have a look at that later. So what we can do is like we can run the program now. So you can see the all the different types of variables here: integer, float, string, boolean, list, and dictionary. So we should now move on to local functions. So a local variable is a variable inside of a function that can only be used inside of a function. So you can't like it's defined inside a function, but and you can't use it outside. So whenever I interact with local underscore var here, so I can only use it inside here. So we call this a local variable. And opposite of this, it's a global variable, which can be used like in the whole program, like it can be used throughout anywhere here. And it can be a global variable can also be used inside of a function. Then then we have constants, and constants are unchangeable values. Like it's actually like constant; it doesn't change. So for example, we have pi here, like 3.14159. So we can reuse it within like different like text and print statements over here. Like the only difference between constant and a variable is that a variable can vary. You can change the value of a variable, but you can't change the value of a constant. So we'll just run the program again so you can see the last part of it. So the constant pi is 3.14159. You can see here. So in Python, constants are just variables that you agree not to modify. So now just move on to user interactions. So the program can interact with the user in many different ways. Like one of the most common ones is like taking an input from the keyboard from the user. Like so now you can see here like name is input, please enter your name. So what this does is like it clears a space in the memory for the variable name, and it asks the user to enter a value for a name, like they type it on the keyboard. Then they put the value inside the variable. So there's just like a one-line statement for it, but if you're just learning from a beginner's perspective, you can just break it up into different lines. So you can understand what actually goes on inside the computer more. Here, another one we have. What we have is the thing is whenever you enter a value from your keyboard, it automatically the program assumes it to be a string. So here we have age underscore str. So we input and enter your age. So you probably enter your number most likely. So like I don't know, like 20 or something. So this 20. It may appear the same as the integer, but it's actually a string. So you can't like do many things like adding it, subtracting it with other numbers. So what we have to do is like turn it into an integer, which is like we can use this function here for like int, and you put the variable age str inside it. That becomes so this value here age that's an integer. So we can do subtraction, that is we can do arithmetic operations on integers such as like 2023 minus days. I will give you the birth year. So then we have multiple inputs. So you can write a statement like this, like you can put two variables here and then you can get input and enter two numbers separated by a space. And you can use the split function over here. That's just like it just automatically like it splits like the whole string based on where the space or like where the white space is. So in this case, since they're separated by a space, when you split it, it just turns it into two different numbers. And we can convert integers into floats here. This is what we're doing. So that just turns a number into a decimal. For example, if you entered 1 over there, it will just become 1.0. So when we add these numbers together, it will give the sum, and then we can print the sum over here. So, and we also have formatted output. It's actually like a bit more advanced topic. So like this is more like this just allows you to control like when you run the program like exactly where in the terminal the answer appears. So now we move on to print options. So you can print multiple items like by putting a comma. There's another method actually where you can just like have one like entire quotation box and you can just like put pluses inside here, and that just prevents you from using commas. So and then you have custom separators. Like you can you can print all of these and it will have dashes between them. So like you put SCP, then you define what the separator is. You can't do that with the plus method I told you earlier. So now what we're gonna do is we're gonna run the whole thing, so you can see what we were just talking about. So I'll just enter my name. I'll enter my age as well. So it just shows, it just takes my name. So I gave it my name. It didn't know my name from before. So now it just says hello, just welcome to the Python input and output demo. So now I told it my age. So it says you were born in the year 2008. Now we have enter two multiples separated by a space. I entered 3 and 5. So it added them up and now there's 3 and 5. Their sum is 8. Now we have the formatted output. So we'll just go back to the section of the formatted output. So just gives you name Alice age 30, height 1.75 meters. These are just various different methods of writing the same thing, as you can see. Some of them are like older and less recommended. I'll just leave all of them over here so you can see it. So there are many print options as well. So separation, you can see there are dashes between here. Then we have for I in range 5. So what it does is it just repeats like every number from 0 to 5, except for 5 itself. So it just separates them all into space, as you can see here. Now we move on to escape sequences. So these are also like a bit more advanced of a concept. So you mainly use this when you're interacting with strings. So there are many of them. So first, the most common one is the new line one. So it's a backslash n. It inserts a line break in the string. So it basically does the work of an enter key. And then we have backslash t, which is the tab. So it inserts like a large block of white space. So it inserts the tab space. So you have two backslashes. So it inserts a literal backslash in a string since the singular backslash is used to denote the escape sequences. A single code, since it has actual function in Python, you have to denote it with a backslash to make it like literally be a single quote. Then it's the same for a double quote. Then for a carriage return is a backslash or. So it moves the cursor to the beginning of a line without advancing to the next line. Then we have a backslash b, so with backspace. It moves the cursor one character backward. And we have a backslash a, which is a bell which produces an audible bell sound. This is like a bit quirky. So we have a new line example. So it prints new line, so we will see that. Then we have the tab, backslash, a code, the carriage return, backspace, bell sound. We have everything. So I'll just run this first. So for new line, you can see that every line here it's in like they're all in separate lines, even though they're written in the same statement. For tab, you can see that they're indented from the left here. Subcategory 1, 2, and 3. Then we have the backslash. Double backslash used to represent a single backslash in a string. So see that we have two backslashes here that are visible, and here we have four. So this backslash over here, it just denotes that we have to put this one inside, and it's the same this thing does for the other one. This does for this. So we have four here. So these two and these two are one, and the other two are one. So for quote examples, to put literal quotes here, like you can see here, we have backslash quote here. Same for like hider. Then for carriage return, you can't really see it here, but like it moves the cursor to the start of the line, allowing text to be overwritten. So first, initially it was loading colon 0%. Then it went back and changed it to loading 50%. Then it changed back to loading 100%. Since we just ran the program, it just updated on its own. So we didn't really see it here. For backspace, here you can't see it either. It said hello world, but the world got backspaced and not just hello Python. So it was initially printed, but then it just got deleted due to the backspace. So for bell sound, I don't think my device's volume is up. So I don't think you really heard the bell sound. But just trust me, it works. I'll try to increase the volume. The problem with the bell sound is that it's not available in every single terminal. So sometimes it works and sometimes it doesn't. So in my case, unfortunately, I don't think this is working. So we'll have to fix that. And I think that's the end for today. So thanks everyone for watching and see you later.